Okay, in this video we're tackling reading radians for this unit circle here. And so to do so, we have that formula that goes and changes degrees to radians, but we don't want to go ahead and do that every single time. Let's come up with some counting patterns to make putting the radians on the unit circle a little bit easier. So let's start here. We know that 0 radians is, or 0 degrees is 0 radians. So these two are going to be the same. If it's 0, it's 0. And we also learned that in one turn around the entire circle, how many radians are in one turn around the circle, which is going to be 2 pi. So let's go ahead and use this information to go ahead and start to formulate the different parts that we're going to need to break down to label the radians correctly. Okay, so if there's 2 pi radians, okay, in one turn around the entire circle, then a half a turn must be 1 pi radian, okay? And so if halfway in between 0 and pi, there must be pi over 2 radians. Okay, so that means pardon me, not half a radian, pi over 2 radians. Okay, and so this is like 1/2. This is a whole, and so this is going to be 3 pi over 2 radians, which is going to go ahead and be like 1.5, and then we're back to 2 pi radians right here. Okay, so it's easiest to go ahead and get those labeled first, and then we're going to take a look at a little bit of a counting trick to get all the different 45 degree and 30 degree increments. So here we go. Okay, so this is the way that I like to show students to knock this this thing out for the 45 and then the 30 degree increments. Is that, first of all, there is going to be a number, and then it's going to be in front of pi, and that the number that's going to be on bottom that we're going to for the denominator is going to be the number of slices that the 1/2 turn is going to be. So I know that sounds weird. This is 1 slice, 2 slices, 3 slices, 4 slices, and so therefore this number under here is going to be 4. And with that, then I can just go ahead and count around the circle, increasing that number sign by 1 each time, starting at 0 until I get all the way around the circle. So let's go ahead and see what that looks like. Okay, so the first is going to be, and we already have it as 0, but that would be like 0 pi over 4, which we know is going to reduce to 0, okay? Then this next one for 45 degrees, I'm going to bump that 0 up 1, because that number sign is always going to change, and it's going to be 1 pi over 4, or just pi over 4. This is going to be 2 pi over 4, but we know that 2 over 4 reduces down to 1/2, which gives us that. The next one is 3 pi over 4. 4 pi over 4, which the 4's cancel out, and we know that we're just going to get pi. 5 pi over 4. 6 pi over 4. 6 over 4 reduces down to 3 over 2. 7 pi over 4. And then 8 pi over 4, which 8 over 4 reduces down to 2, which you're going to go ahead and get this business at 2 pi. So that's what we're doing. We're counting this number right here is going to increase, starting at 0, increase by 1 each time, and this is the number of segments, or the number of slices in one turn around the circle. Okay, so we're going to do the same thing for the 30 degree angles. Okay, so for all the increments of 30 degrees, we're going to take a look at this guy right here, which is a number that's going to increase from 0 till we're done all the way going around the unit circle. And the 6 on the bottom represents 1, 2, 3, 4, 5, 6. Okay? And so therefore, that is, again, we want to take a look at one half turn around the circle. How many slices are there? And that bottom is going to stay the same, and that number sign is going to go from 0 all the way around, reducing it as necessary. So let's take a look at how this is going to work out. Okay, so here we go. This is going to be like 0 pi over 6, which is 0. And a lot of these are duplicates. I'm just doing it for a quality of life thing, for instruction. This is going to be 1 pi over 6, which is pi over 6. This is going to be 2 pi over 6, which is going to reduce down to pi over 3. 2 over 6 reduces down to 1 over 3. 3 pi over 6, 3/6 is the same thing as 1/2. 4 pi over 6, which is 4/6 is going to reduce down to 2 pi over 3. 5 pi over 6, which is just going to stay as is. 6 pi over 6, where the 6's cancel out, and we just end up with pi. 7 pi over 6, can't reduce it down. 8 pi over 6, 8/6 reduces down to 4 pi over 3. This is going to be 9 pi over 6, which reduces down to that. Okay. 10 pi over 6, which is going to reduce down to 5 pi over 3. 11 pi, 11 pi over 6, which is going to stay as is. And then finally, this is going to be 12 pi over 6, which is going to, 6 goes in the 12 twice, which just gives us our 2 pi. So to clean everything up, this is what the final unit circle should look like. Okay, so there it is, all cleaned up, okay, and we have all the degrees labeled in different shades of blue, and then all the radians labeled in different shades of green, and we're going to be accountable for being able to label those and visualize those out to use the unit circle in a rewarding fashion. So our next video is going to tackle how to go ahead and fill in all these parentheses and use them to go ahead and evaluate trigonometric ratios. So I'll see you in that next video.